Now, what they tend to do, an exam question that they tend to ask for these, flip over the page. I think hopefully you got these ones as well. Can you just make a note? That should be -2 minus y, okay? All right, so at this point now, how do we look at exam questions? The exam questions relating to slope fields will be one of the two things, typically. It will be, okay, I'm going to give you an equation. So in this case, we have -2 minus y. Can you match that up with a graph, okay? Or we can go vice versa and we can say, all right, here is 4 equations. Can you match that up with this particular graph, right? And the thing you want to think about is just go back to what these represent, right? Y dash, right? Y dash, James, what does y dash mean again? The derivative, right? This is the gradient. So always come back to that. Can you make a note of that on your sheet? This is the gradient. So basically, right, one way of doing it is if you think about this, okay, y dash is dependent on the y value that's there, okay? Think about, all right, substituting in a value and see what happens, see what you get out. What should the gradient actually be? Because you can actually literally test points here, right? So let me give you a coordinate, for example. I'll just write it alongside here. So if I'm putting in a coordinate here, right, 0, 0, what would my gradient be? If I put in 0, 0 into this equation that I've got over here, because we're literally just substituting in points, -2, right? Because the y coordinate is -2. Now you might have noticed, hey, there's actually no x coordinate in there, and that's actually going to help us determine what graph it's kind of talking to, right? So the gradient is -2. So what this does is it lets you eliminate some of these options, right? So if you go to the origins, for example, if I look at A, what do you notice about the gradient of the isocline at A? What is it? Well, let's zoom in. What kind of gradient would you say at 0, 0? What kind of gradient does this isocline have? It's positive, right? Does that match up with that one? No. Right, so you can see this is a way you can eliminate an option because A doesn't work because it doesn't satisfy this condition. Yeah? Does that kind of make sense, right? What about B, Kyle? How does B look? Does that B look like it could match up? Yeah. Yep, that one's good. We'll leave that there for now. C, Callum, what do you reckon?
Yeah, it does. Yeah, no, not C, sorry.
Oh, okay, C as in not C. Okay.
Yeah.
So D is fine, is what you were saying? Because that gradient there is negative?
Yeah.
Yeah, okay, we'll leave that in there for now as well. C, we can immediately rule out as well, okay? Yeah, all right, awesome. All right, other things we want to think about. Now, one way you could do this is you could just keep substituting in points over and over and over again. And sometimes you might have to do that because there might not be a better option. But I guess I want to show you some things to highlight that you may kind of look for in your graphs, right? One thing I mentioned earlier was that there is no x value in this actual differential equation, yeah? So what you want to think about is what would that mean? If I change the x value, how does that change the gradient? So think about what I just said. If I change the x value, how does that change the gradient if there's no x in the actual equation? Sorry? It won't, exactly right. So what that means is if you look at your graphs, basically if you change the x value, the gradient of the isoclines shouldn't change, right? Because here I've got 0, 0. If I did like x, as in if I did like 5, 0 here into this equation here, well, even though I've changed the x variable, the differential equation, that gradient won't change, right? So the gradient will still be -2 because if I put in 0 into this equation, I'll still get -2, right? So I want to have to think, okay, which one of these graphs looks more like that? D, right? Because if you look at it, the gradients, if you move along each of these points, right, along the x-axis, all of these gradients are actually the same. All of these gradients are actually the same. So you can see it's not dependent on that x variable, whereas this one, they all change as you go across, okay? Another thing you might look for, look at what we have over here, right? These horizontal lines, how do I get a gradient of 0 in my equation? Well, if I go back to the original, if y is equal to -2 here, you can see that this thing becomes 0, and so that's why D is another match for that, okay? So you can see the process that's involved, right? There's a lot of things that we have to put into place. We test some points. I usually test the origin as the first kind of thing. And then we go and see what other things are interesting, right? Does it only have y? Are there any places where the gradient is 0? These are the things we want to look for, yeah? Let's try the next one together. Okay, this one, they both have x and y now in the equation. So I'm looking at that, I'm like, okay, sure. Okay, that's not going to help us out. But again, I want to test the origin. What do you notice about testing the origin here? Okay, so this is an issue that sometimes happens with differential equations, that you test in the origin and you get 0 and 0 here. I actually don't think that there should be a horizontal line at each of these origins, because it looks like there are, but we'll ignore that for now. Yeah. But what else do you notice? Well, if you have, for example, at y is equal to 0, right? If I have let's test a point that's not the origin. Let's test like, let's test 1, 1. Okay. That's a bit nicer. If I tested 1, 1, y dash is equal to 1 minus 1 on 1, and that gives us 0, right? So at 1, 1, I should have a gradient of 0. Let's highlight all the 1, 1s and see which of these match up. So which ones look good? B and D again looks like. Okay, cool. B and D are good. A and C we can rule out. All right, perfect. Okay, so B and D are looking good. What else can we do to kind of distinguish them?
Well, if 0 and 1's kind of wonky, it's probably not going to be a point there. Or it might be, I don't know.
Yeah, ignore the y values of 0. I need to go back to that. There's something not quite right there. But we'll
make it D though.
Ignore it for now. Ignore that for now. Let's just try use another condition.
I mean, we can just do like 2, 1.
Okay, let's try 2, 1. Okay, cool. So let's put in 2, 1. Okay, and so we get y dash is equal to 1 minus 2 on 1. That's going to give me y dash is equal to negative 1. Okay, so go across 2 up 1. So that's usually a different color. Across 2 up 1. We've got this guy, and we've got this guy there. And as James noticed, hey, the gradient really should be negative 1 here. Okay, and only one of these meets the condition. This guy's positive gradient, as you can see. This guy is negative, which is the one we want, so B is the answer for that. Okay. Any questions about that? No? Okay, awesome. All right, next, we've got 2 more. Have a crack for me.